Hi dear students, how are you? I hope you're fine. Today we are going to talk about the revision of grade 9 quarter 3. So let's start. We have here the trigonometric here ratios, remember. So I have, when I talk about the here trig, so I'm having here the sine, cosine and the tangent. Okay guys, if I have here to study, so I'm going to study a very here easy word. This word is Sohcahtoa. Yes, we are talking about here Sohcahtoa. Here soh, it means sine equals what? Opposite over hypotenuse. What about ka? It's here the cosine equals what? Adjacent over hypotenuse. What about tua? It's t, the tangent equals o, which is the opposite over the adjacent. Okay, okay. So when I ask you here, what is the sine of angle? What's the sine of angle A? So sine, it means that we are talking about, so it's opposite over what? Hypotenuse. The first thing I have to know here, where is the opposite and the hypotenuse and the adjacent. The opposite here, it's the angle, it's the side in front of the required angle. It's the side in front of the required angle. What about here the hypotenuse? It's the side in front here of what? In front of the right angle. Okay, so this is the right angle and this is what? This is my hypotenuse. See, here is the hypotenuse. Remember, hypotenuse is the longest here side on the right angle triangle, and here it's fixed. And if I ask you about the adjacent, remember the adjacent, it's the side between the required angle and what? And the right angle. So this here, if I ask you here, I want the sine of angle A. This is very easy. So I say it's what? So it's opposite over what? Over adjacent. It's A over C. So opposite over, sorry, hypotenuse, it's A over Z, because we have so opposite over what? Hypotenuse. If I ask you here, what is the cosine of angle A? Cosine of angle A, this means that we have here so ka here, it's what? It's adjacent over hypotenuse. So I need here cosine of angle A, so ka. So adjacent, what is the adjacent? It's here, I told you, it's the here space length between the required angle and the right angle. So it will be B over, I said here again, so ka. So we have over hypotenuse. Hypotenuse is fixed here, C, B over C. And I have here, what about the tangent? Tangent means tua, opposite over adjacent. So I got here, if I say the tangent of angle A, so ka tua, opposite, which is here A, over what? Over adjacent, tua, over here B. Okay guys, easy. Let's have an example here together. Here he asks you to write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. So we have here and he asks you about sine of angle J. This is the question. He asks you to write here trigonometric ratio as a fraction and as a decimal, guys, and gives me which one? The sine of angle J. So sine of angle J equals what? Sine, so it's opposite over what? Hypotenuse. What is the opposite here? It's 60. Hypotenuse, it's the side which is in front of the right angle, gives me here 61, and we are using calculators this quarter, so it will give you guys after rounding 0.98. Okay. If I have another example here, he asks me here about what? Find the unknown measures, round the length to the nearest hundred and the angle measures to the nearest degree. Okay guys, I have this is 58, this is 90. So what is this angle? I have total measure of angles equal 180, we know that, and here we have 90 plus what? 58. So we got the remainder is what? 32. This is from quarter 1. So we got here guys 32. Okay guys, I need now to know the length here of DF. Okay, I need to know the length of DF, and what else, and the length of what, of EF. Since, okay guys, so if I know that here, what about if I used tangent of angle? Okay, we have here, this is 32. If I said I need what, guys, I will ask myself, I need EF, I need EF. Okay, this is, okay, we need the marker again. This is 32 and I need this EF. I need to know it. Okay, and I need to know this also. So if I say tangent of angle 32, because I know the measure of angle 32, tangent of angle 32, it's what? I need the opposite, and I need what else? I know here the opposite. Okay, I want you to imagine I have here the opposite, and I have here what? Remember that, the adjacent. So if I say and I have this 32, I have this 32, and I have this 14, and I need to know this side. So which here one that I will use? It's tangent of angle here 32, because tangent equal to opposite over adjacent, because I don't know the hypotenuse. That's why I use tangent of angle 32. So it will be tangent of angle 32 equal EF, which is required, that I don't know, over the adjacent, which is 14. So guys, I remember, if I want to this, it will be EF times 1 equals 14 times 32. So EF equals what? Equals tangent 32, tangent 32 times what? Times 14, multiplies 14. Okay, by using the calculator, I got here EF equal 8.75. Okay, and this is after rounding the length to the nearest 100th. Okay, what about, I have here now EF. So I want to show you, we have here now EF. I want here the, yes, I want here this. If I know two here sides, okay, and I want to know this side, how can I do it? By using what? The Pythagorean theorem. Yes, I can hear you, because we have a right angle triangle, two lengths. So use your Pythagorean theorem. The hypotenuse, remember, it's very easy. The hypotenuse here equals what? Equals the sum of 14 squared plus what? Plus EF squared. Okay, why? Because this is the here Pythagorean theorem. So I will write df power 2 equal ed power 2 plus ef power 2. Give df power 2, which is the hypotenuse required, equal 14 power 2 plus 8.75 power 2. By using the calculator, you'll find df. Easy, guys? I think it is. If I have here another question, the Seattle Space Needle casts a 67-meter shadow. Okay, if the angle elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle round to the nearest what meter? Okay, asks me here. I will give you this. I will not ask you to draw, so I'm going to give you this here figure and ask you here, what about here y? What is the length of y? So guys, we have a right angle triangle. This is very important note. So I can have here what? That trigonometric ratios. So I'm going to use it. So we have here, this is 90, this is 70. So, and I need what? I need y. Okay guys, I need this y. And I have what? And I have this angle. Okay, opposite over what? Opposite over adjacent. Remember, this is the tangent. What about tangent of angle 70 equal what? Y over 67. Guys, it's very easy, and I will do the same steps as if I did here up in the previous example. So tangent 70 equal y over 67. So how can I get y? Tangent 70 times 67 gives me y. I can do it like cross multiply. Y times 1 equal tangent 70 times 67. By using my calculator, I will find that it will be 184 meter. Okay guys, now we're going to have another lesson to revise it. The law, okay, the law of sines. So what's the law of sines? If I have here this time an acute triangle, so for any triangle ABC with side length ABC, sine of angle A over this side A equals to sine of angle B over this side B. It's very easy. Sine of angle B over this side C. Okay, guys, can you see it again? Okay, so if I have an example like this, find the measure, round the length to the nearest tenth and angles to the nearest degree. Okay, guys, we have the information here on the figure. So he asks me to find xz, this xz. Okay, how can I do it? This is not a right angle triangle to use the trigonometric ratios, but I can use the sine and the sign here, the law of sines or the law of cosines. So I have here what, guys? I will use xz power 2, xz power 2 equal xy power 2. Okay, guys, now I'm using the law of cosines. Okay, and I will show it to you again. So I have, what's the law of cosine? This is the law, guys, of cosine. So this is what, if I have here xz power 2 equal xy power 2 plus yz power 2, but this, it differs than the Pythagorean theorem. Pythagorean theorem, remember, right angle triangle, but this, the cosine here rule. I'm talking about the cosine rule. So xz power 2 in acute triangle, so xz power 2 equal xy power 2 plus yz power 2, but we have extra thing, minus what? Okay, the two sides here multiply each other. So 2 times xy times yz, okay, cosine what? Cosine here, the angle between. So this is the law of cosine. Okay, guys, remember this well. So the law of sine, I want to revise it with you. Sine A over A, sine C over C, sine B over B. Okay, here the law of cosines, remember, this is what, round the length to the nearest ten. Okay, he asks me to find xz, and this is not a right angle triangle, so I will use here something near to the Pythagorean theorem, but it's called the law of cosine. The same, but we are having here extra thing, xz power 2, it's xy power 2 plus yz power 2 plus minus, okay, minus what? Minus 2 times the two sides together, cosine the in between angle, which is angle y. So let's do it together. Okay,